Okay. So today's lesson will be... Oh, I'll put my mic closer. So today's lesson will be focused around, in general, how do we separate, more like how do we design purely data-oriented objects? What separates a data object and an object with business logic? How can we call them? What we shouldn't do with our data objects and with objects in general, and we will try to cover when to use which access modifier and law of Demeter. So, and also data validation. So let's get right to it. I will open Twitch chat just in case. Okay. So let's start with a second look at encapsulation. Encapsulations essentially is grouping similar variables and restricting access. We already covered how to group variables, but we didn't really cover how to hide them, like how to get a guideline on which access modifier to use when. So I'll try to analyze each access modifier at least available in C# language. Let's start with a meme. There is a meme which goes like this. When someone comes to us and we know that that person just rambles and rambles and talks and doesn't stop, we usually want to stop that. We usually want to prevent that from happening. We don't want someone random talking with us for a long time. We don't care about the details. When we want to talk with that person, we will, but if we don't have to, we won't, and we avoid that. What do? No details when we don't need them is an essential part in programming. We shouldn't enforce others to know more than they should. And for that reason, classes shouldn't talk too much. Classes should expose what is needed the most, and that's all. So we don't want to listen to a ramble, and we just want to have what we need. Magic happens in code, that's true, but it's beautiful when it does what we want, but not necessarily without telling us how it does that. That's the beauty of programming, having that black box kind of attitude. Private variables is the key to hiding details. It's the modifier that should probably be used most often, I would say. And it says that something will be hidden to the outside, and the outside meaning that even the child classes will not know about the parent, what it has, as long as it's private. And this is great, and this should be used when exposing it otherwise has no meaning to the outside. So why do we need private then if it has no meaning to the outside? You might ask. Well, if you find yourself passing the same variable around to multiple methods multiple times, it's wise to have a local object state, thus having that variable inside an object. And instead of passing it, you can reference to it through private access modifier, through a private field that you assign the value to. So it's really important to make your life easier and play smart, be smart with access modifiers. Private is a go-to in most usual cases. So that's about it. Protected is second access modifier. It's basically a shadow of a parent class where you have no need of exposing it to the public, yet you want it to be seen by the outside, by the others. By the others, I mean by the child classes. It only applies in inheritance. And you shouldn't use it if you don't plan something to be inherited, but it doesn't have to be inherited already. Just make it, think about it, and if you think that it can be inherited, make it protected if it's needed in the inheriting class, because otherwise they won't be able to use that private variable. This might not be so evident and apparent in your own projects, but when you work in teams with multiple projects, multiple packages, assemblies, and so on, a simple detail like that might mean a lot. It might be a give or go if someone will use your package or not. It's discouraging not being able to do what you want, even if it's such a simple and small thing that's missing. Internal is something that I personally haven't used that much in the past, but in the present I use it a lot. Internal is very important when working on projects which are with intention of being used outside. Let's say you're making a library which you're planning to use to other projects. Maybe you're planning to release it to the public so that everyone uses your library. And maybe some classes are related and you have to expose it in order to use something of an object. Let's say a variable in that object needs to be used by another object, but you wouldn't be able to use it otherwise if it wasn't public. But at the same time, you don't want third-party people to see that variable at all because it's not needed. It's only needed to some group of objects, but for other group of objects, it's unrelated and they don't want to know about it. And if that's the case, it should be internal. Having a group of classes inside the same assembly or packaging, seeing a variable marked with internal makes that variable only visible to those grouped objects in the same assembly. It's access modifier, which basically works like private, except for the scope of assembly. If private is private to the scope of class, internal is private to the scope of assembly. Internal protected is a way of saying that you can hide something to the outside assemblies, but you can also you also basically give them a way of inheriting it and giving them a chance of getting the functionality, extending the functionality that was nested inside some class. So it's like a ghost. If internal was a ghost bound to a project, an assembly, then internal protected is a ghost which is bound also to an assembly, but it can move in shadows, just like protected was a shadow of something. So is internal protected a shadow which is an actual thing inside an assembly. So if you think that details aren't necessary but might still want to give a chance of extending your class, you should use internal protected. I actually only used it once in my lifetime because this is an extremely rare case, but it's a well thought thing to put it when it's needed. So think about it. Public is what people overuse, and it should be used with great caution, because when too much is being public, it's not really about exposing too much info, it's about exposing too much noise, where there is so much that it's hard to find what we actually need. So filter what we don't need with access modifiers restricting access to what should be hidden. Sealed is a way of saying that it's not really an access modifier, but it's simply a way of saying that a class should not be inherited. So when you're sure that implementation is complete, you should mark a class as sealed. Also, when you think that someone can break your class with inheriting it, you should also mark it as sealed. If you don't want the class to be inherited, seal it. And here you can see access modifiers in C#. Public, private, protected, internal, and basically key thing here is that internal and protected internal are for assembly scope, and others are for global scope, for outside assembly as well as inside assembly. The next topic is data validation. And why do we need data validation? We need data validation because we want to keep integrity of data untouched. So we don't want duplicate data, we don't want missing information, we don't want inaccurate information or information with incorrect format. And data validation lets us do just that. Keep its integrity so that we are in control without the unexpected errors happening during runtime longer down the line. And when it happens, we might see something like null reference exception, key missing in dictionary, and something ugly like that. And we don't want to see that because it's really hard to pinpoint an error when it's too late. So we need to validate stuff, and we need to validate it early. Because with data integrity, we can ensure that data that we're processing won't cause errors. We won't need to revalidate it if we know that the model itself is valid. So if we validate each part of it all the time, we won't need to revalidate it when we consume it. Where do we validate it? And the place where it can be validated immediately is the model. The model lets us validate itself so that we fail early. When we feed something to a setter, we can do a validation. When we feed something to a constructor, we can validate the data that we get through it. And if a client inputs something, we can validate that as well for a client understandable way and give information to a client that he inputted something wrong in the correct format and so on. So if we want client-side validation, then it should be done in some sort of a controller. Manual validation is done through a setter or through a constructor. In this case, when we set first name, we will first validate it. And if it's invalid, and in this case it's as simple as checking if value is not null or empty, we will throw an exception that data is invalid, and we will say name cannot be empty. When we validate data, we should throw an exception without an error code, rather with a description which gives us contextual info. What went wrong? Preferably why it went wrong. And then we will know where and how to fix it, probably. If validation is complicated, then class itself should not validate itself. So in those cases when there is a lot to validate, a class should have a validator from the outside. So in this case, maybe it's fine. A more pretty way would be splitting it to the outside, putting validate method to the outside, but it's fine as it is. It's at least validated, so that's what matters. Another way of how we can validate data is using what a framework provides. In C# we have attributes, and some attributes can be used for validation. You can make your own attributes or use pre-made attributes for you. And there is a bunch of attributes in C#, and basically the main ones you can see here. You can have an attribute for a required property, for property length, for range, and so on and so forth. There are various attributes that you have in C#, and you can see a full list in the link down below. Now let's talk about data transfer objects and POCOs. What are POCOs anyways? Data transfer objects, DTOs in other words, are basically just pure data. They shouldn't contain any logic and they shouldn't process themselves. They should be consumed by something from the outside. And the outside is POCO. POCO is a business logic object, but with one exception. It doesn't have persistence to itself. It basically serves as something which does processing. It doesn't save itself, but it can contain logic to saving something else, but not itself. That's the difference between DTO and POCO. And procedural flow via DTOs. Basically, when you don't use any POCOs and you use only DTOs, you can have something like this, where you feed pure data transfer objects into some controller, geometry controller in this case. So you have a square and rectangle and circle, and you need to count their area. And you count their area like that. So on the left and right, you see both parts of the same code. It's taken from Clean Code by Robert C. Martin in a section where it talks about procedural flow. This is procedural flow because we are not using what object-oriented flow would provide us. Rather, we're checking the type and we're doing a bunch of ifs. So step by step, we're checking what can be done and we do it. It's not pretty because we need to do those ifs, and ifs are not nice. How can we make it better? By using POCOs. In this case, square is not simply data. It's a bit more. It's a logical concept. It's not just data. So a square can calculate its own area. Square and rectangle can do that both. They're both a shape. And basically when we call this, we can create two shapes and calculate their area. The output will be the same. The thing about this is that we have two approaches, procedural and object-oriented. With procedural code, it's easy to add new functions without changing the existing data structures. but it's hard to add new data structures because all the functions need to change. So with this approach, well, first let's cover OP approach. It's easy to add new classes without changing existing functions. It's hard to add new functions because all the classes must change, right? Think about it. Hard to add new functions because all the classes must change. Easy to add new classes. Is it a problem that it's hard to add new functions? Not so much. I mean, we won't have a big function, and all those small classes will have little to do. They might have more functions, but they will have little to do. There might be changes in multiple places, but usually conceptually logic doesn't change. We might need to change implementation, we might need to add features, but we usually change implementation more often than adding features. So OP approach is better, right? Procedural approach is problematic because it involves everything. It does multiple things. It processes shapes conceptually, yes, and you might think that's a single thing, but it processes squares, rectangles, circles, and OP code lets each function to be responsible for itself and let polymorphism handle it. So a square, a circle, and a rectangle each knows how to calculate their area, and shape and extraction of each defines that each of them should let us calculate area. So OP code lets us have the open-closed principle implemented easily because we work through polymorphism, through polymorphic behavior, and our changes will be external. If a new shape is added, and that's what most likely going to happen, we won't have to change other shapes. But with procedural code, it will impact the existing logic for calculating space of shape. And that's a really big problem, and we want to avoid that. And lastly, today I wanted to cover law of Demeter. And I think this one here is also quite important. Law of Demeter, in my interpretation, is law of train wrecks. When you have a little train of chained calls together. This is extremely evident in linku calls in C#, where people don't really understand that they're doing more than one thing. And long linku calls are simply unreadable. It can be, as long as conceptually you're working with a similar concept. If, let's say, you're filtering something, then that's fine. But if you're filtering something that was already filtered, that's not fine. It's not fine when they are essentially two different things and you're refiltering from another thing. So why is what does law of Demeter tell us? Law of Demeter tells us that it's a bad idea for a single function to know the entire navigation structure of the system. So when we call something, we should only be able to call its immediate member, nothing deeper, nothing else. So we should operate through properties, through methods in general. We shouldn't know about the internals. And there is a principle coming from that: tell, don't ask. And there are 4 rules basically what can be called from an instance. So you can call past arguments, something that's created locally, instance variables, and globals. Nothing else cannot be called. So let's look at the bad example. We have a guest person and a household. Inside a household, there is a house. Inside a house, there is a kitchen. Inside the kitchen, there is a fridge, and fridge holds food supplies. And we want first food supplies. And that's how we get food that we can feed to a guest. This is a bad implementation because by simply requesting for food which household can provide, we need to go and know the whole chain of structure that household contains. We don't want to know about it, we don't want to be aware of it, and we want to eliminate such train. That's what a train looks like, because each dot is like a wagon attached to the train and chained together. We don't want that. A good implementation would be having giveFood method inside household class and household simply requesting giveFood, simply simply telling giveFood from itself, so that inside we handle how we do it. In giveFood method, note that we don't call a slightly shorter chain, but we call only the immediate properties. So when we access kitchen, we know that we can access kitchen from a house. When we access fridge from a kitchen. When we access food from the fridge. We don't access fridge from house, kitchen, but we access it from kitchen. And that's the difference, the core difference in the implementation. That we only call our immediate friends, our immediately accessible members. So I said that linku is often a violation, but it's not always a violation. I mean, usually it helps. Fluent API is a style where you chain together where you chain together method calls. A builder pattern is an example of Fluent API, and here is how it looks like. On the left side, you see an example of Kata SQL. It's a library for querying SQL in a linku kind of way. So you have methods for filtering. So you say that you want to get something from posts where likes are more than 10, where in something, where not null, and so on and so forth. Like this, we can define, like this, we use a fluent way of having no need of recalling the provider for those methods. We don't say query.where, query.wherein, query.where not null. We can chain those methods together. How? If you look on the right side, you see class query and implementation of how where would look like. In the end, we return itself, the instance itself, the class which has the method itself. And through that, we can chain those methods together and have no need of calling it again. So that's called Fluent API. And that's all I wanted to talk about for this lesson. I will give a bit more examples on next Friday. So there will be a second look to objects and data structures because I prepared this at work as well. So I will try to make this presentation a little bit better next time. Thank you for watching today and see you the other day.